Alright, so I want to go back to the basics of graphing just to kind of refresh. Whenever I'm going to graph something, a lot of times we will have a set of ordered pairs, or an X and a Y. And the X and the Y tell me two things. The first one, and they will always be in that order. It'll always be X, comma, Y. They're in X, just like in the alphabet, X comes before Y. Now when I see these on a graph as a set of ordered pairs, you're going to have two numbers. Let's say I had the ordered pair 2, 3. Okay, if this is my X, the X always tells me left or right. Okay, and the Y value always tells me up or down. Alright, now that'll always go that way. And when I'm plotting a point, let's say I'm going to plot the point 2, 3 on a graph. If I'm going to plot that, this is a positive 2, so it tells me that I'm going to go to the right 2 spaces. Well, when I'm starting a graph, I'm always going to start at the origin, the very middle of this graph. Now this is my x-axis, it's horizontal. That's why the X always tells me left or right. Now this vertical axis up here is the Y, the one that goes up and down. That's my y-axis. Okay, and it's always going to tell me up or down. So if I'm going to plot these 2 points, the X value was positive 2. That means I'm going to go to the right 2 spaces. And I'm always going to start at the middle of this graph, at the very center, the origin of this graph, and I'm going to go right 2, 1, 2, and then I'm going to go up 3 spaces, 1, 2, 3. So my point is going to be right there, okay? From the origin of the graph, I went right 2 spaces and up 3 spaces. That's what those 2 points were telling me to do, okay? And I always have to follow that order. I'm always going to go right first, and then I'm going to go up, okay? Now, you might get negative numbers in your set. Let's say I have the numbers -2 or -3, -4. That's telling me that I'm going to go left instead of right. Now negative numbers are always going to be to the left, and negative numbers on the y-axis are always going to be down. Okay, so we have those two contrasting points there. So let's say I had the opposite of that. Let's say I had +3, +4. That's telling me I'm going to go right because it's a positive, and positive values are always going to be from the origin, are always going to be to the right. And that +4 tells me I'm going to go up. So negatives are left if they're x values, down if they're y values. Positives are always going to be right if they're x's, up if they're y's. So let's say that I was going to take this point over here, this -3, 4, and I put this on the graph. Well, I start from the middle of the graph, and I'm going to go -3, that's my x. I'm going to go left 3, 1, 2, 3, and I'm going to go down 4, 1, 2, 3, 4, and I'm going to put a point right there. So that would be that -3, 4. That's where that would be on the graph. I'm going to go left 3, down 4. Now don't count where I started at. I started at the origin, and I'm going to go over 1 box, and I'm going to count 1 when I hit that first line. I'm not going to count the middle as 1, okay? So you'll be off by 1 if you do that. Alright, now if I were to graph this other point down here, this is +3, +4. If I were to graph that, I'm going to go from the start from the center, I'm going to go right, 1, 2, 3, and then I'm going to go up, 1, 2, 3, 4. And that's where that point would be if I were to graph it. So these are two, the signs make a huge difference. They're in two totally different quadrants of the graph. One I had to go left and down, the other one I had to go right and up because the second one was positive, the first one was negative. Alright, so when you're plotting points, just pay attention to which one is which. And it's always going to be x and then y, just like in the alphabet, x comes before y. If it's positive, I go right for the x values. If it's negative, I go left. And then the y values are always going to tell me up or down, positive or negative. Positive is up, negative is down. Okay, so let's say I gave you something in what we call slope-intercept form. Now, slope-intercept form, we always say it looks like this. Y equals mx plus b, and that's just a way of writing, and this is the way it'll always be. If it's a linear function, it's in slope-intercept form. Whatever's in front of x will always be my slope, and this last number over here will always be my y-intercept. Okay, so if it's in slope-intercept form, that's what you're going to have. You're going to have a slope and you're going to have an intercept. And the ones we're going to be dealing with in this unit are linear. They're going to make a straight line. So I have this slope and whatever is in front of x. So let me give you an example of that. Let's say I had y equals, and if I give you slope, when we talk about slope, remember slope means rise over run. In other words, up and down over left and right. So when we're talking about slope, that's what I'm talking about. So if I were to give you a slope, and let's say I gave you the slope 2 over 3, and that was in front of your x. Okay, and then let's say the y-intercept was 4. Okay, alright, so this is in slope-intercept form. I've got y equals 2/3 x plus 4. Alright, now this positive 4 over here, my y-intercept, that's where I'm going to start. So if I have a line and it's given to me an equation and it's given to me in slope-intercept form, this is always telling me where to start. Okay, this is saying start at positive 4. And it's the y-intercept. Okay, so my y-intercept is positive 4. So this last number right here, the constant, the y-intercept, this is my starting point. So I'm going to go to the y-axis. I'm going to start from the origin. I'm going to count up 1, 2, 3, 4. So I'm at 4. Oops. 1, 2, 3, 4. I'm at 4 on the y-axis. Y-intercept, where does it intercept the y-axis? Where does it cross the y-axis? So this is essentially telling me where to start. Okay, so this 4 is telling me where to start on the y-axis. And this over here, this slope, is telling me where to go. So I know where I'm going to start. I'm going to start at positive 4 on the y-axis, that vertical axis. And this up 2 over 3, that's my rise over my run. So from the y-intercept, I'm going to rise up 2, 1, 2, and I'm going to go over 3, 1, 2, 3, and that's where I'm going to put my point. And I only need 2 points to make a line. I could keep going. I could say up 2 over 3 and make another dot if I wanted to, and then draw my line. Okay, so I got this line right here that I could draw. Now, my slope is constant here. It's up 2 over 3, and I could keep repeating that to the right. My y-intercept, that's where I'm going to start. I started at positive 4 on the y-axis, and that's how I would graph a line if it was in slope-intercept form. Now, they're always going to give us, and you know, when we're talking about linear functions, it's always going to be given in slope-intercept form. We're going to have 2 pieces of information. We're going to have the slope and we're going to have the y-intercept. Now, it doesn't always have to be positive numbers. Let's say I had y equals negative 2/3 x minus 4. Okay, you can have negative slopes, you can have negative y-intercepts. It doesn't really change anything. But if that was the line that I was told to graph, I would say, okay, well, this is my slope, this is my rise over my run, this is my y-intercept. It's just telling me where to start. So I'm going to start at negative 4, so I'm going to always from the origin, that's 0 in the middle of the y-axis. I'm going to go down 4 spaces, so 1, 2, 3, 4. That's my y-intercept at negative 4 on the y-axis. And then the slope is just telling us where to go. So if I look at my slope, that negative is up there with the 2. One of those numbers is going to be negative. So since this 2 is negative, and that's my rise, it's telling me actually to go down because it's negative 2. And then I'm going to go to the right 3. So I got a down and I'm going to go to the right. So from there, I'm going to go down 2, 1, 2, and then I'm going to go right 3, 1, 2, 3, and that's my point. This graph, this particular graph, has what we call a negative slope. Right? And when we look at a graph and we talk about positive or negative, I'm always talking about from left to right. If I was to be, if let's say I was walking in this direction, this is me walking in that direction here, left to right, I'd be going downhill. Okay, so this is a negative slope. If you ever play those old video games like Mario Brothers, you're always moving from left to right to kind of go to the next level. I'm going downhill from left to right. That's a negative slope. So if you look at the slope and it's negative, and they're asking you to match the graph to the equation, a negative slope will always go downhill as we go from left to right. If it's positive, then that slope's always going to be going uphill. And I would always go, oh, okay, well, if it's positive, it has to be going up as I go from left to right. It would be a positive slope. Okay, so the signs, don't let those throw you. If it's a negative slope, I'm going to be going down and right. If it's a positive slope, I'm going to be going up to the right. Okay, so that is how we would graph a line if it was in slope-intercept form. All right, now what if a line, or if a graph, if we're given the equation of a graph and it does not have a y-intercept? Now that's going to happen every now and then. You'll see an equation and it'll look kind of confusing because it'll just be like, oh, y equals 2x. And you'll go, okay, well, where's the y-intercept? There's not one. If you don't see a y-intercept, a number that's there, that just means that there is nothing there, 0. The y-intercept is 0, so that's telling me that I'm going to start at the origin. So if you just see something like this, y equals 2x, understand that there's no y-intercept, that y-intercept is actually 0. Okay, now they're not going to put the 0 there. It's just going to look like y equals 2x. Now, and that brings us to another thing, is if you just see a whole number, you can make any number a fraction by putting a 1 under it. So now my slope is going up to right 1. These are both positive numbers. So I would start from the origin and I would go, okay, well, I'm going to go up to 1, 2, and I'm going to go right 1. It's going to cross the origin of that graph when I graph that line. So you may see lines like this where they don't have a y, I mean, not that they don't have a y-intercept, but you don't see it. If there's nothing there, there's literally 0 there. It's kind of like having no money in the bank. So that's telling me that I'm going to start at 0, and it does have a slope. It does have something in front of x, and that's what that's going to look like. And you'll see things that maybe it doesn't give you a slope. It just says y equals 5. Okay, well, there is no slope there. Okay, so that now it's missing the slope. So if I were to really write this out literally for what it is, it's in slope-intercept form. There's nothing in front of x, so 0 times x just went away, but it does have a y-intercept. Okay, so when they show it to us, it's just going to look like y equals 5. What that means is that it crosses the y-axis at 5. So 1, 2, 3, 4, 5. It does cross the y-axis, but it doesn't have a slope. Okay, so if a line doesn't have a slope, you think about the ramp that you go up when you're coming upstairs in Dalton High School. It has a slope. You're going uphill, depending on which direction you're coming. So if you're standing on a floor that has no slope, it's just a level floor. There is no slope. So this doesn't have an up and an over. It's just a flat line. This graph, ooh, that's ugly. This graph is just a straight, solid, there is no slope, there's a y-intercept, so it's just a flat line. There is no rise, there is no run. It's just like the floor that you're standing on, or the hallways when we walk in the hallways. There is no slope, there is no incline. It's just a flat surface, okay? So that would be a line with no slope. It just gives me the y-intercept. It's going to create a horizontal line. Now, once we understand how graphing a line works, you'll be given a graph and you'll be asked questions about the equation or about the line. Okay, so let's say I've been given this graph right here. It's already got the equation graphed. They already have the y-intercept. Now, if I asked you to give me the y-intercept, you would just look at this y-axis right here. Where does this graph cross the y-axis? Well, if you look at where it crosses the y-axis, it crosses at -4. That is the y-intercept. So if I'm asking you for the y-intercept, That's all I'm asking for. Where does it cross the y-axis? So the y-intercept of this line right here would be -4. Now, what about the slope? If I asked you for the slope, if I said, what is the slope of this line? You could start from any specific point and you could just count up and over. If I said, okay, what is the slope of this line? This line is graphed. It does have a slope. I would just go to the line and I would say, okay, well, if I start, let's say I start here at -4 at the y-intercept. I go up 1, 1 over 2, 1, 2. Then that is the slope, up 1 over 2, and it keeps doing that, up 1 over 2. That slope is constant, so it's going up 1 over 2. That's the rise, it went up 1, and that's the run. So that was the slope. So I would say that the slope is just 1/2. How much does it go up? How much does it go over? And I'm just looking for that specific information about this line. Okay. Now you may also be asked for solutions. I might say what points, and if it was multiple choice like the homework, it'll say what are some solutions to this equation, and it's graphed. If a point is a solution to something, that means that it is literally on that line. So if I'm looking at points that are solutions to this graph, any point that appears on this line is a solution to this equation. Alright, so if I gave you these 2 points and I asked you to pick all of the points that are solutions to this equation, now the line's already graphed, let's check this first point. Is this a solution to the equation? Well, if I start from the center, if I start from the origin and I say, okay, well let me go right 2, down 2, because that 2 is negative. So I'm going to go over 2, and then I'm going to go down 2. Is that point a solution? Well, it's not. This point, +2, -2, is not a solution because it does not fall on that red line right there. If there's an equation graphed, that's not a solution because it's not on that graph. Now, if I go to this next point, +2, -3, that's telling me to go right 2, down 3. If I were to follow that coordinates and put it on this graph, well, if we look at what happens here, if I go right 2, starting from the origin again, I always start from the middle of this graph. If I go right 2, down 1, 2, 3, you'll notice that I actually am on the line. Okay, so this one is a solution to that equation, and this one is not a solution because it's not on that line. So when we ask you for a solution and we ask you for to select everything that's a solution, you would only pick the points that are on the graph, on the line of that equation. All right, now you may also be asked to give the coordinates of the y-intercept. Now if I'm asked to give the coordinate of the y-intercept, I just need to figure out, now we know that just by looking at this graph, that it intercepts the y-axis at -4. But how would I write that as an ordered pair? Well, if you start just like we've always done, if I'm trying to figure out where is this graph at as an ordered pair, well, left or right, I don't go left or right to find the y-intercept. I'm starting at the origin, so left or right, I don't go anywhere. So I would say 0 because I'm not moving left or right, but I am going down 1, 2, 3, 4. So the -4 shows that I'm going down 4. So my y-intercept would literally be at the coordinate 0, -4. So if I'm looking for the y-intercept, I always know that the x is going to be 0 because the y-intercept is on the y-axis. That means I haven't moved left, I haven't moved right. The x-intercept is at 0, -4, and it's always going to be at 0 on the x-axis. So if they ask you for the y-intercept, if the x value isn't 0, then it's not the y-intercept. It's only going to cross, the y-intercept is only going to cross where x equals 0. So if you're asked for the y-intercept, you know exactly what to look for.